Good day, listeners and students. I'm Mr. Abiona Kamaldin, a mathematics tutor. The topic before me today is application of trigonometry. For the lesson objectives, students will be able to 1. Apply the principle of trig ratios to solve problems involving angles of elevation and depression. 2. Locate points or places using the 3-digit bearing and compass bearing methods. Before I move on, we need to understand the concept of angles of elevation and depression. And a good scenario to depict that is when we have two students in a place, one on top of a tree and the other on the ground. For them to observe each other, the one on top of the tree must look down and the one on the ground must look up. As a result, the angle of inclination of the one on the ground from its eye level up to the level of the tree is called the angle of elevation of the top of the tree from the ground. And likewise, the angle of declination of the one on top of a tree from its eye level down to the level of the ground is called the angle of depression of the ground from the top of the tree. If you listen attentively, you will observe that for the angle of elevation, I used the angle of elevation of the top point from a lower point. And for the angle of depression, I used the angle of depression of a lower point from a top point. So in the same single scenario, we realize that the angle of elevation of the top of the tree from the ground is equal to the angle of depression of the ground from the top of the tree, because the angles are alternate to each other and hence are equal. This is what we also call Z angle. I have some questions to illustrate the explanation here. Examples. 1. The angle of depression of a point G on the ground from the top T of a building is 23.6 degrees. If the distance from G to the foot of the tree is 50 meters, find the height of the building. Solution. We can see points T and G have been given. T is the top of the building, so just use a vertical line to depict a building and put T at the top, and use a horizontal line to represent the ground and put G there. So they have given us the angle of depression of G from T as 23.6 degrees. From my explanation earlier, it will still be the same as the angle of elevation of T from G, and that is 23.6 degrees. So put 50 meters for the ground there. You can see we have a right angled triangle. So we have tan 23.6 degrees equals h over 50. times 20.6 is 0.4369. So h equals 50 times 0.4369. And h equals 21.845 meters. So approximately h equals 21.85 meters. Therefore, the height of the building is 21.85 meters. So in the next segment, we shall consider other examples of angles of elevation and depression. Thank you very much for listening. You are welcome back to the second segment of today's class. So question 2. The angle of elevation of the top of a tree from a point 27 meters away on the same horizontal ground as the foot of the tree is 30 degrees. Find the height of the tree. Solution. From the question here, you can see that we have been given the angle of elevation of the top of the tree from a point which is 27 meters away and on the same horizontal ground as the foot of the tree as what? 30 degrees. So we want to find the height. You can just use a vertical line to represent the tree and put h as its height. We have been made to realize that the distance between the top of the tree and that point on the ground is 27 meters. So from that, we can see that we have formed a triangle in which the hypotenuse is 27 meters and the opposite is our height. Using our principle of trig ratios, we have that sine 30 degree equals h over 27. So h equals 27 sine 30 and h is 27 times 0.5. So h is 13.5 centimeters. So the height of the tree is therefore 13.5 centimeters. Now question 3. A stationary boat is observed from a height of 100 meters. If the horizontal distance between the observer and the boat is 80 meters, calculate, correct to 2 decimal places, the angle of depression of the boat from the point of observation. Solution. In this case, they have given us an observer is on a height. Use a vertical line to depict that height and put the observer at the top. Height of what? 100 meters. And we have also been given the horizontal distance between the boat and the observer as 80 meters. So that is a horizontal line. We have to find the angle of depression of the boat from the observer. Don't forget from my explanation earlier that the angle of depression of the boat from the observer will still be the same as the angle of elevation of the observer from the boat. So use theta to represent that. Then we can see that we have a right angled triangle and the angle in it is theta. The opposite is 100 meters and the adjacent is 80 meters. Then using tan, we have tan theta equals 100 over 80. So tan theta equals 1.25. Then theta equals arctan 1.25. So theta equals 51.34 degree. Hence, the angle of depression of the boat from the observer is 51.34 degrees. Let us quickly move to the concept of bearing. Bearing means location of points on the surface of the earth. Majorly, we have two methods of locating our bearing. The first one is the 3-digit bearing, while the second one is the compass bearing. In 3-digit bearing, we are concerned about 3 digits, and our reading must always be in reference to the north and in a clockwise manner. I have some examples here to depict the definition I've given. In the next segment, we shall continue from there. Thank you very much. Welcome back to the third segment, how to identify your starting point in a bearing. This is simply talking about reference points. How do we identify our reference point? A very good example to explain a reference point can be taken from the direction segment in the invitation card we often receive anytime we are invited to a party or an event. We realize that there is a place for direction, and there are so many ways of writing that direction. Here I will give us some. We can have in the direction segment, from Bega, board a bus to Obalende. Another one can have it as board a bus to Obalende from Bega. What the two are informing us in that is that before we can get to Obalende, we must get to Bega first. So that Bega that we must get to first is like our starting point, and it is what we mean by the reference point. So let us use some examples to illustrate this. Questions. 1. The bearing of Ade from Kunle is 060 degree. Find the bearing of Kunle from Ade. Solution. The 060 degree that you can see there actually means 60 degrees. But because we must have it in 3 figures, so it means we need to add one more 0 anytime we have 2 digits. You add it before the number 060 degree, 070 degree, and so on. That is why we have 06 degree, 060 degree. Now the next thing is, how do I identify our reference point here? From what we have said earlier, it means immediately after the preposition from, we see our reference point. So it is the noun or pronoun that follows the preposition from. So here I have from Kunle. So Kunle is my reference point. I need to identify Kunle first. Just go to the middle of your notes and put a point to represent Kunle. On that point, draw your 4 cardinal points: north, south, west, and east. So we are locating angle 60 degree. Don't forget that in 3-digit bearing, you must always start our reading from the north, and you move in a clockwise manner. By the time we are moving from the north, we need 60 degrees. It means it will not get up to the east, because between the north and the east is 90 degrees. So 60 degrees is just before. So identify where you have 60 degrees and draw the line from the point representing Kunle. It means it will go up. So on any point on that line, we can have our Ade. But assuming we are given a measurement for the distance, then you will need to measure it. But this is still all about sketch. So it means our Ade will be on any point on the line. Then when you get to Ade, draw your 4 cardinal points there. So the question being asked now is that what is the bearing of Kunle from Ade? It means our reference now is Ade. So you go to Ade and you read from the north of Ade in a clockwise manner up to the line that is going to Kunle. If you look at that, it means that you pass the east, pass the south. Immediately after the south is where you have the line going to Kunle. So from the north and south, we have 180 degree. That is north to the south, 180 degree. So what do we now add to it? We add a small angle between the south of Ade and the line going to Kunle. But from what we have learned before, we have what we call alternate angle, the Z angle. The angle between the south of Ade and the line going to Kunle will be the same as the angle between the north of Kunle and the line going to Ade. So it means that will be 60 degrees, 060 degree. The bearing of Kunle from Ade will now be 180 plus 060 degree, which is equals to 240 degrees. So it means the bearing of Kunle from Ade is 240 degrees. I have some assignment here for us. Question 1. From the top of a vertical cliff, 20 meters high, a boat at sea can be sighted 75 meters away and on the same horizontal position as the foot of the cliff. Calculate correct to the nearest degree the angle of depression of the boat from the top of the cliff. 2. The bearing of y from x is 120 degrees. Find the bearing of x from y. So other questions are y.